All right, so we are continuing with section P6. I don't have that title on here, but this is P6 continued. We're going to do adding and subtracting and complex fractions today. So there's a procedure for finding the least common denominator, because you have to have common denominators to add and subtract. And then I have some steps on adding and subtracting rational expressions. So if you look at these steps, you're going to factor all the denominators, determine the LCD from the factors, multiply the numerator and denominator of each by any missing factors to form the LCD, add or subtract the fractions, simplify if possible. Most of what I give you is not going to simplify, okay, once we're done. All right, so let's determine the LCD. So to find a least common denominator, you have to factor the denominators completely, and then you're going to form your LCD by multiplying all of the factors from the first denominator with anything in the second denominator that's new. Okay, so you don't have to repeat factors unless they're repeated in the same denominator. Okay, so again, things usually make more sense when you see an example, so let's try one. All right, so number 8, we already have common denominators, so you're just going to skip to the part where you just subtract the fractions. So remember, when you subtract fractions with common denominators, you keep that denominator, and then you just combine the top. So this minus sign, remember we do plus the opposite, so I'm going to make it plus and then change both of those signs. So I have x plus negative 3x. And then we have a negative 2. All right, so the last step says to simplify if you can. So I just want you to mentally think, can I make this look like this? And I think if you pull out a negative 2, then you can make them match. And you'll just get negative 2 as your answer. Okay, so number 9, we do not have the same denominator. So I can make a common denominator, and I'm going to try to not show every single little step that explain anything that I'm skipping. So we have x plus 1, x minus 1, because these guys will not factor. So my common denominator is just going to be the two of them multiplied together. All right, so to jump to this denominator from here, he gained an x minus 1. So his numerator has to gain an x minus 1. To go from this to this, he gained an x plus 1. So we're going to have 5 and x plus 1. All right, so this is where I'm going to try to not show all of my work. Right here, when I multiply this out, I get 3x plus 3. That did not work, did it? 3x plus 3. Here, when I distribute this, I get 5x plus 5. So I'm just going to add. So it's 3 plus 5, so 8x. And that's a minus, not a plus. So let me fix that. That was supposed to be minus 3. So now we have negative 3 plus 5, which is 2. All right, so that last step of simplifying, if you think about pulling something out of here, you're still going to have a number, because all I can do is pull out a 2. So this would still end up being a 4, which isn't going to let me cancel. So there's no point. We can just stop here. Number 10. You need to factor your denominators before you can come up with a common denominator. That's not a plus sign. It should be a minus sign. So for this trinomial, we're going to get 2 binomials. And I believe x minus 3 works. Yes, because that's positive 9. And then negative 3 is negative 6. All right, and then for this, we're going to do x plus 3, x minus 3. All right, so we no longer have those denominators. We have these new factored ones. All right, so for your common denominator, you take everything in the first one, and anything that's new over here. So x minus 3 we've already got, but x plus 3 is new. All right, so minus 3, and the plus 3. All right, so to go from here to here, we gained an x plus 3. To go from this denominator to our new common denominator, we gained an x minus 3. So we're going to figure out what the numerator needs to be. So we're going to keep that same denominator. All right, so to save me a little bit of writing, I'm going to do my work up here. This is 3x plus 9. This is 7x minus 21. So we'll have 3 plus 7 is 10x. And 9 minus 21 is negative 12. Yes. All right, so again, if you look at what you got and you think that factoring that's going to allow it to cancel with the denominator, then try it. But I can't take 10 all the way out, which means I'm never going to get a plain old x as the first term. So it's not going to simplify. If it will simplify and you forget, it's only going to be like a minus half or something like that on your test. So I don't think you really need to concern yourself that much with the simplifying. Okay, number 11. Factor the denominators. This part says minus 5, minus 5. Yes. Take out a 2 as a GCF. So we no longer have those denominators. Our common denominator is x minus 5, because it's both pieces of this. And then anything new over here, which is just a 2. All right. And I want you looking up in a minute and being like, what the heck are those? So I'm going to try to fix them a little. All right, so here's our common denominator. Okay, so all we gained here was a 2. So 2 times x. Here we gained an x minus 5. So we have x minus 4 and x minus 5. All right, so no work to be done here, but this we're going to have to multiply out before we can subtract. So my common denominator, I'm going to go ahead and get myself ready. Here we're going to get x squared minus 5x minus 4x, so negative 9x, and then plus 20. All right, so you have minus, so make it a plus and change all of these signs. And now just combine your terms. So 2x and 9x can go together and make 11x. This negative x squared and negative 20 just need to come down there with it. All right. I don't think this factors at all. So we are done. All right, so that's adding and subtracting. Factor your denominators, find a common denominator, adjust the numerators as needed, and then combine them. All right, so this next thing that we have is complex fractions. All right, so a complex fraction is a fraction that has a fraction in its numerator or its denominator or both. So complex fraction means big, ugly fractions with lots of little fractions. All right, to simplify, there are 2 methods. You can simplify by doing the operation indicated and then simplifying, or you can eliminate all of the little fractions using an LCD, which is the method that I choose to use. I think it saves a lot of steps. So that's what I'm going to show you is method 2. All right, so for number 12, if you look, you have 1, 2, 3, 4 fractions basically, because this is over 1 and this is over 1. So the common denominator for these 4 is just an x, because you have a 1 and an x as your denominators. All right, so if we take our common denominator, we figured out that the LCD is x. So all I'm going to do is multiply each piece of the problem by x. All right, so what that's going to do for me 1 times x is x. Here they cancel out. And so I just have minus 1. Here I get 3x. Here the x's cancel out, so I just have minus 1. And I am literally done. All right, the one on your test is kind of more like that one than like the next one, just so you know. All right, so step 1 on this one is you have a denominator that you need to factor. All right, so I'm going to rewrite the problem just so it doesn't get too jumbled up and factor this. So we need x and x, we need positive 5 and negative 3. And nobody else has a denominator that needs factored. So I'm just going to write them all down. And I changed that 1 to 1 over 1 just so all of the pieces look like fractions. All right, so find an LCD. So the LCD for this problem, you have x plus 5, x minus 3 in one denominator. Here you have an x minus 3, that's already there. Here you have an x plus 5, that's already there, and a 1, which is understood to already be there. So for every term, we're going to multiply by x plus 5, x minus 3. When you multiply something, it multiplies on top of a fraction. You don't have to show this step, but it's easier if you show it so you can see what's canceling and what's not. All right, so let's go through and see what cancels when we do that. Here, those all go away. On this term, the x minus 3's go away. On this term, the x plus 5's go away. Here, nothing cancels. So my next step is to figure out what I have left. All right, so in this piece, all I had left was a 6. In this piece, I have an x plus 5, and it's minus, so I'm going to do minus x minus 5. In this denominator, I have x minus 3, and then here I need to multiply that out. All right, so all I have left is to combine some like terms. And then you are finished. All right, so like always, if you have questions, please let me know. I'm happy to help.